Welcome to SAT 021. The topic of this lesson is solving system of equations algebraically. We learned how to solve a system of equations from the graph. We can also solve a linear system by substitution or linear combination. Substitution first. Let's look at one example. Which of the following order pair satisfy the equations y equals 3x minus 1 and x plus y equals 7? And there are A, B, C, D, 4 choices. Okay, so to solve a linear system by substitution, there are 4 steps to follow. Step 1, solve for one variable, meaning you need to isolate one variable, x or y, by itself. And in this case, y equals 3x minus 1, the first equation, y is by itself already, so we don't have to do anything here. Step 2, substitute into the other equation and find the value of the variable left. So we are going to replace y in the second equation by 3x minus 1 from the first step, all right? So the second equation, no more y, it's replaced by 3x minus y, and then we're going to combine like terms, solve for x, and x equals 2. So now we know the value of one variable. Move on to step 3. Step 3, substitute the value back and find the value of the other variable. So we know x equals 2. We need to find the value of y. So substitute x equals 2 back to any equation. And here we're going to substitute back into the first equation, y equals 3 times 2 minus 1, and y equals 5. And then step 4, don't forget to check the solution. Okay, so we're going to substitute 2 for x and 5 for y in the original equations, and they need to make both equations true. All right? Okay, A is the correct answer. X equals 2, y equals 5, and that's a point. The order pair is 2 and 5. Now let's look at a practice question. What is the value of x plus y based on the system of equations half of x minus y equals 3 and x plus 2y equals 4? And there are 4 choices, A, B, C, D. Okay, so we're going to solve this linear system by substitution. Remember step 1? Step 1, solve for one variable. Actually, we can choose solve for x or solve for y. Okay, here we choose to solve for y in the first equation. Okay, so move y to the right side and then move 3 to the left side. Okay, and then step 2, substitute into the other equations and find the value of the variable left. So we're going to substitute half of x minus 3 into the second equation to replace y. So the second equation turns into x plus 2 times no more y. Instead, it's half of x minus 3 equals 4. Distribute, and then we combine like terms, simplify, and then x equals 5. Then step 3, remember step 3, we need to find the value of y, right? So substitute the value back and find the value of the other variable, which is y here. So x equals 5, back to any equation, and here we choose the second equation, replace x by 5, and then we solve for y, and y equals negative 0.5. And then step 4, check the solution. So substitute 5 for x and a negative 0.5 for y in the original equations. And actually they are the solution. Okay, they make both equations true. But don't forget the question. The question is asking to find the sum of x and y. So x plus y equals 5 plus negative 0.5. So the sum is 4.5. D. Okay, the other method is called linear combination, and I'm going to use an example to show you how. So the question is, the xy plane is used to graph the system equations 0.6x plus 0.2y equals 0.7, and 0.2x minus 0.6y equals 0.5. Find the order pair x, y of the point of intersection, and there are A, B, C, D, 4 choices. Okay, so now we're going to use the method called linear combination. The steps are slightly different. Step 1, rewrite the equation in standard form. And here, both equations are in standard form already, so we don't have to do anything. Step 2, multiply equations by integers so the coefficient for one variable are the same. Then subtract the equation or the opposite, then add equations, and then solve the variable left. Okay, let me show you. Okay, so these are the two original equations. When we look at the coefficient of x and y, we realize if we multiply the first equation by 3, and then that turns into 1.8x plus 0.6y equals 2.1. The coefficient of y in the first equation is 0.6, in the second equation is negative 0.6. They are opposites. Okay, so we're going to add these two equations up. So positive 0.6y plus negative 0.6y, so there's no y left, only x left. Then 2x equals 2.6, so x equals 1.3. Okay, so we can see y is eliminated by this method. And then step 3, substitute the value back and find the value of the other variable. Okay, so we know x now, we need to substitute back into any equation, and here we choose the second equation, and we solve for y, and y equals negative 0.4. And then step 4, don't forget to double check. Okay, so check the solutions, substitute 1.3 for x and a negative 0.4 for y in the original equations, and they make both equations true. So that means 1.3 and negative 0.4 is the correct answer, B. Okay, so one more practice question. Find the value of y if x, y is the solution of the system of equations 2x plus 3y equals 5.1, 0.5x plus 1.5y equals 1.2. Okay, so read the question again. We need to find the value of y. Okay, so that means eliminate x is a good idea. Okay, so let's do it by a linear combination. So when we look at these two equations again, we look at their coefficient. And then we realize if we multiply the second equation by 4, we will get 2x plus 6y equals 4.8. Then the first one, unchanged, 2x plus 3y equals 5.1. Now the coefficient of the x in both equations are the same, 2. And when we subtract the second equation from equation 1, okay, remember subtraction here. So no more x left. 3y minus 6y is negative 3y. 5.1 minus 4.8 is 0.3. So y equals a negative 0.1. D is the correct answer. Okay, so that's all for today. Thank you for watching. Goodbye.